The learning objective of this module is to gain a high-level introduction to cell culture process development. I want to take a moment to outline the course. We will be covering introduction into expression systems, generation of recombinant cell lines, antibody production processes, process optimization, process scale-up, product quality in manufacturing, and finally, quality by design and PAT. Let's start with the introduction into expression systems. The following expression systems are widely used in the production of biopharmaceuticals. They are bacteria, yeast, and mammalian cells. It is important to factor in the desired product to the advantages and disadvantages of these expression systems. In the next few slides, we will cover some of these. First off, we'd like to cover bacteria. Some of the advantages are that we have a long regulatory track record, we have a very short processing time, we've got low risk of contamination, processes are easily scalable, they are very cost-effective to run due to simple growth medium, and we have no unintended glycosylation. Here are some of the disadvantages. We have intracellular expression, which means that often a shock is required to cause product release from inside of the cell. This could be pH or temperature. In some processes, cells must be ruptured to release the desired product, resulting in high endotoxin and host cell protein challenge to purification. And finally, no post-translational modifications are available. Next, we will look at yeast. Here again, some of the advantages. We have a long regulatory track record, short processing times, low contamination risks, easily scalable, cost-effective due to simple growth medium, no endotoxin risk, low host cell protein burden, and again, some of the disadvantages are obtaining desired product glycosylation is challenging, and yeast versus human glycopattern are different. Finally, we'll turn our attention to mammalian cells. Some of the advantages are molecules expressed are in their native form. The cells secrete the desired product. Complex molecules can be expressed. Expression vectors are easily obtainable. High degree of process understanding is there. We have large regulatory experience. Finally, some of the disadvantages are long processing times, complex growth medium, higher risk of contamination during processing. Now, we will be getting back to the complexity of the growth medium a little bit later on in the presentation.